In this video, we extend the idea of section 1.8 limits to section 1.7, which is a section called continuity. Okay, and in section 1.7, we just need a pretty straightforward definition here that a function f of x is continuous. This is the word I'm defining. Continuous at x equal to a if three things happen. If three things are true. Okay, the first thing that has to be true is that the function f of a has to exist. Okay, that means that the function at a does not exist. Does not exist. The function has to exist. Okay. 2, when you compute the limit of this function, the limit has to exist. So the limit cannot not exist. So there has to be a limit in the function. Okay. 3, the third thing that has to happen is that the limit value that you found from step 2, that's an x, sorry, that the limit as x goes to a of f of x has to equal to the function value. Okay, and let's show an example right here. Okay, we'll come down here and create a graph. So this section really utilizes a lot of graphical techniques. Okay, so here's the x-axis, here's the y-axis. Okay. I'm going to draw a function here. Let's say this is 1, so it's the function is part of a line, and then it ends up around 4. And let's say there's an open circle there, and then the rest of the function picks up and goes like this. Okay, and there's a closed circle, and let's say that that straight line, this little straight line segment, is at 6. Okay. And then we'll close this function off at, say, 4. So here's 0. So here's the graph of a function. It's a straight line. Okay. And here are some questions we could ask, just some things to observe or to note. Okay. First things to note. This function at 0 is equal to 0. There's an open circle. Okay. And it's at 0. 2. The function value at 1. Take a moment to think about what the function at 1 is going to be. The choices are it's either 4 or 6, right? But there's an open circle here at 4, so when the function is 1, its value is not 4 because there's an open circle. The closed circle is at the y value of 6. Okay? And then 3, the function value at 4 is equal to 6 also. Okay, so we're just testing out some of our function values, okay, just to see if we're recognizing this graph. Okay, so let's choose x is equal to a. Let's choose that equal to 1. Okay, 1 is our point of interest. Okay, and let's ask ourselves, let's go through the 3 continuity questions. The question, is this function f of x continuous at x is equal to 1. Okay. 3 things have to happen. Does the function at 1, does it exist? And you say yes, the answer is sure, the function at 1 exists. We found that function value to be 6, so that's a check. 2, does the limit exist? Does the limit as x goes to 1 of f of x, does that exist? Can you find it? And this is where we're going to have some difficulties because this limit doesn't appear to exist because from the right, as we get close to 1 from the right, okay, from the right, the limit is equal to 6. But from the left, the limit appears to be, as x gets closer and closer to 1, the limit is getting closer and closer to 4. And those are not equal to each other. So the limit does not exist here, So the answer to the full question is that no, this function is not continuous at x is equal to 1. Okay? So, there's a non-example, we call it. Okay. Let's look at another example. Add page below. So we can see here from that last example that, right, this kind of makes sense that this function is not continuous, right? There is a jump in the graph. You try to draw this graph, and then you have to pick up your pencil to draw the rest of the graph, right? So there's some non-continuity going on there. Okay. So let's go to the next page and take a look at this example. Okay. I'm going to make up a new function, x and y, and I'm going to call this the function g of x. Okay. We'll call this 1. And let's say that the function was straight line segment again, an open circle, and then the function comes down, right? And then we'll do this, let's say 4. Okay. So let's ask ourselves a couple questions about this graph to see if we're on board with it. Okay. 1, can you tell me what the function g of 0 is equal to? 2, can you tell me the function g evaluated at 1? Okay. G evaluated at 0. The y value of this point is 0, and the y value of the function at 1, right? There's an open circle, so we're passing through that, and we can see that the y value of this function is equal to 4. Okay. Could you interpret what you think is going to happen, the limit as x goes to infinity of this function g of x? Right. You kind of have to interpret that this graph seems to be on a downward slope, and if you extend this graph, it looks like it's going to keep heading on. Just based on the graph, I would probably have to say that this limit as x goes to infinity of g of x. This function seems to be heading downward and downward and getting closer to 0. And, you know, that's just kind of what we have to infer from that graph. Okay. All right. Now let's answer the question that we're going to have here. Is g of x continuous at x is equal to 1? Okay. Remember, there are 3 things that had to happen. Did g of 1 exist? And you say yes, because g of 1 was equal to 4, so it did exist. Okay. 2, does the limit as x goes to 1 of g of x, does that limit exist? Okay. And as we're getting closer and closer to 1 from both sides, we can see that our limit does exist. It's getting closer and closer to something from both sides. What is it getting close to? We didn't label that. We'll say that it's getting close to some number L. I don't know what that number is. It's a number less than 4. Okay? But you would say, yes, the limit exists. Okay? Yes, it's equal to some number L. Okay? Third question. But that number L, we're agreed, is less than 4. I mean, the limit is less than 4. Okay. Third thing, to be continuous, the limit as x goes to a, or limit as x goes to 1 of g of x, was that equal to g of 1? G of 1 was equal to 4, but our limit was equal to some number less than 4, so those two are not equal to each other. So this is another non-example of a function that is not, this function g of x is not continuous at x is equal to 1. All right. So finally, we need to actually do an example of a function that is continuous. So let's go ahead and try one of those now. Okay. Let's add a page below. Again, I'll draw a graph. A lot of this section is graphical, trying to come up with your own sketch of a function. Let's say that the function h of x is a piecewise defined function. Let's call it 2x. And this is for values of x when x is less than 2 but greater than 0. Okay, and then the function is 4 when x is greater than or equal to 2. Okay, so let's take a look at this function, h of x. We've been given a formula, and let's see if we can create its graph. So h of x, it is a linear function, 2x, so it's an equation of a straight line with slope 2, until you get to x is equal to 2. So from 0 to 2, notice that I didn't put equal signs here, so we have open circles. Okay, and then when x gets to be bigger than or equal to 2, we are the straight line that is equal to 4. Okay. And notice that as x was getting closer and closer to 2 from the left, then the values of the function seem to be getting closer and closer to 4. So this graph is consistent with our thinking. Okay, so here's a graph of this function, and then it's now filled in right there at that dot by the line y is equal to 4. Okay, so the question is this function, is h of x continuous at x is equal to 2? Okay, and the answer is, okay, 3 steps to go through. Does h of 2 exist? Sure, h of 2 exists. When x is equal to 2, right, because of this greater than or equal to, the function value is 4. So this function exists and it's equal to 4. 2. Does the limit as x goes to 2 of this function h of x, does that limit exist? And sure, the limit exists. From the left, we're getting closer and closer to 4 along this straight line, this diagonal straight line, and as x gets closer and closer to 2 from the left, we're getting closer to 4 along this flat line. So we're getting close to 4. 3, does the limit as x goes to 2 of h of x, does that equal to h of 2? And sure enough, it does. 4 is equal to 4. So here's an example. H of x is a continuous function at 2. Okay. Another video will walk you through another one of the Wiley Plus problems on continuity.